All right, my voice is breaking. I understood that. Okay, so welcome to this problem-solving session on database management systems. Few people call it databases, whatever you call. In these problem-solving sessions, we will actually do some important problems that are there in your subject. I will be honest, since I didn't teach you the lectures, and I have not been very thorough with the concepts, although I know the concepts very well. But few of the things I will may not be able to say you right in today's class. Um, but obviously, I will teach you how to solve problems, and that's the idea, and that's why I kind of agreed to take these sessions because um, I know how to solve problems, and that will be the idea. As far as the internal details of concepts and all go on, that you guys are more expert in it, and I'll just try to help you in revising your concepts that are there in your subject. So the plan to cover this lectures are like this. There will be in total 7 lectures, and we'll start with ER model, and we will go with something called functional dependencies. You might have studied that. It's a huge important topic for your gate. Then we'll go with normalization, we'll go with relational algebra, relational calculus. We'll look at SQL, which is also one of the most important topics. Transactions is also a very important topic. So the main focus will be on two, topic two, topic five, and topic six. Others are also important, and obviously topic three. Without topic three, databases is not complete, right? So file structures, I mean, it's okay. It's a good topic to learn. Lot of overlap with data structures and algorithms about B plus tree, B tree. Relational algebra, relational calculus is also a very simple topic. Today we will be actually going with questions on ER model. And ER model is one of the most important ways to model a database, right? Apart from relational model, which you might have studied already. ER model also rhymes with ER diagram. So you might have also studied ER diagram. And since it's a problem solving lecture, the format will be I will give you some time to solve. Maybe I have 10 questions, okay? Not much, 10 questions I have for each topic that I will teach you. In case there is a concept that has to be covered in a greater depth, I will be happy to do that. So there will be 10 questions on today's topic, which is ER model. And I'll give you some time to solve, about 4 to 5 minutes per question. I will give you some time because I assume you guys have either lost touch or you're doing it for the first time, and then we will discuss the solution. Okay, so let's start then. This is your first question. It was asked in GATE 2024. Please take some time to solve it and let me know if you have any doubts. Okay, any answers? It's a simple one. It was asked in this year gate. Okay, I have an answer. Weak entity set must have total participant in that relationship. Okay, any other answers? No other answer. Okay, answer A is correct. Very good, Shruti. Answer is perfectly okay. Okay, let's go step by step. Okay, since I have not taught you the concepts, so I assume you don't know anything by now. So I'll try to teach you in about 5 minutes all these things. Okay. Okay. First of all, let me ask you something. Okay. What is the meaning of a strong entity? Anyone? What do you mean by a strong entity? Have you been taught this concept? Let me first ask this. In your class, please don't say no. Sorry, I don't want to pressurize you. Okay. Have you been taught this concept? Strong entity, weak entity? Yes, no. No? Oh, this is very sad. Okay. Okay. Have you been taught about ER diagram? Yeah, that's fine. That's fine. That's fine. That's perfect. Okay. So you say only till attributes and types. That's fine. See, typically I will tell you. Okay, don't worry. It's a very simple concept. So let's take a person. Okay. Now this person has some features. Okay. He has some features. He or she has some features. One of them, let me tell you, is let's say name. Okay. One of them is let's say age. Okay. One of them is let's say gender. Okay. Any other attributes that a person can have, which you guys know? Come on, just say anything. There are many. You guys use your mobile phones. You have something in your mobile, a SIM card. A SIM card has something called a mobile number. Each person has a mobile number. Does a person have one mobile number or it can have more than one mobile number? Yeah, come on. I have more than one mobile number, right? I have a personal one. I have a work one. Many people have nowadays more than one mobile number. Perfect. So let's say phone number. Okay. What else? What else? What else? So he or she can have a date of birth, right? If he or she has a date of birth, then maybe I will put age in a dashed ellipse. Okay. What else? For example, if someone wants to uniquely identify a person, let's say in India, okay, my domain is only India, okay, I'm not talking outside India. Let's say I want to uniquely identify a person in India. What is the way that I can identify him or her uniquely? Every person has only one of this number, Aadhaar number. Perfect, perfect. That's what Aadhaar number. So Aadhaar number is a another feature. Okay. Now, if you see, I have drawn something in rectangle. As you see, I have drawn something in ellipse. Have I drawn it just like that, or there is some meaning? What do these ellipses mean? These ellipses are features of a entity. So what is the entity here? The entity is a person. It's like a thing, it's like an object, okay? The person has some features. He has a name. He or she has a name. He or she has an age. He or she has a gender. He or she has an Aadhaar number. He or she has a phone number. He or she has a date of birth, right? All of these are different features, and features are represented using ellipses. You can see all these are ellipses, right? Name, age, gender, Aadhaar number, all these are ellipses. Person is an entity, while person, the feature that a person has are different attributes. Okay, perfect. Now, as you can see, there are some special ellipses I have drawn. For example, phone number is drawn as a double ellipse. You can see that, right? There are two circles I have drawn. What does that mean? Why would you think the person phone number is drawn in a double ellipsis? What could be the reason? I asked you a question before writing phone number. Yes, Vishnu, you are saying something.
No, Aditya, I was just saying it might be an unique entity or a unique attribute, sorry.
No. So, perfect. No problem. So, the phone number person can have more than one phone number, right? Can a person have more than one date of birth?
No,
Can a person have more than one age? No. Can a person have more than one gender? No. But a person can have more than one phone number, and and that's why it's called a multi-valued attribute. So it is represented in a double ellipsis. Okay, this is a multi-valued attribute. Okay. Okay, that's about double ellipses. Now, what does this dash mean? Okay, for example, let me reveal it. Okay, my date of birth is 24th April 1997. This is my actual date of birth. Okay, this is my date of birth. Can you calculate my age? What is my age according to the date of birth? I've just given you the date of birth. Can you calculate my age? Yes, no, yes, no. 27 years, perfect. 27, some people may call 28, 27 and a half, whatever you say, right? But you can calculate the age given the date of birth. So if I remove the age attribute, will it make any difference? Will I be losing any information?
no.
No. That's why it is also called a derived attribute. What is a derived attribute? A derived attribute is an attribute that has a value derived from another attribute. Okay, you can use the date of birth to calculate the age. That's why you don't need the age. It's a derived attribute. Okay, is it clear, everyone? What is a derived attribute?
Yes, it is.
Yes, everyone? Perfect, perfect. And multi-valued attribute? Any other example of multi-valued attribute that you may think of? If a person lives in more than one house, can he have more than one address? Yes. Can he have more than one address? Sure, he can, right? Let's say you own two houses. Let's say you have two places to stay. Let's say you stay in your college, which is one address. Let's say few people have something called communication address. Few people have something called permanent address. So that is also one of the multi-valued attribute. Okay. The last type of attribute that I would want to talk about is like this. See. So let's take a person again. Okay. Okay. The person stays in an address. And when it comes to address, you can just maybe directly write the address, whatever address you have. For example, XYZ, XYZ Nagar, XYZ place, whatever you write. But few people want the address to be broken down into different methods. For example, they want the address to have, let's say, three fields. One is the building number, which building number it is. Second could be the street. Third could be the city. and the fourth could be a pin code, right? So it could also be written like this. So an address is kind of broken down into these four different attributes. Okay, so again, let me again say the same line. The address is broken down into four different attributes. That's why this address is also called a composite attribute. It's a composition of different simple attributes. That's why it's called a composite attribute. The address attribute is composed of four simple attributes, which is building number, street, city, pin code. Okay, is it clear now? Any questions so far? See, I'm just scratching the surface. Okay, I'm not going very deep. Okay, I can go very deep, but again, it will take a class. Okay, so I'm just scratching the surface so that you can solve the question. But as you can see, till now, I have still not said what is a strong entity. I have still not said, right? I'm just talking about entity, attribute, and all that. Acha. Okay, let's come back to the question. Among all the attributes that are given for a person that you can see here on the slide, which attribute can uniquely identify a person? Is there an attribute that can uniquely identify a person?
Gender.
Gender of how? So you have a gender male, I have a gender male. How can you uniquely identify me?
Okay.
Aadhaar number, right? All of us have different Aadhaar
Hmm.
number, right, Vishnu? Like I have an Aadhaar number which is unique. You have an Aadhaar number which
Yes,
is
yes.
unique.
Hmm.
Others have an Aadhaar number which is unique to others. So Aadhaar number is one of the attributes that can uniquely identify an entity. That's why this attribute is also called a key attribute. This is called a key attribute. So what is a key attribute? A key attribute is an attribute that can uniquely identify an entity. And to represent a key attribute, we underline the attribute. So the attribute is Aadhaar number. We underline Aadhaar number to say it is a key attribute. And if an entity has a key attribute, it is called a strong entity. Okay. If an entity has a key attribute, it is called a strong entity. Is it clear what is a strong entity? Yes. Okay. Perfect. Perfect. So now what do you think is a weak entity then? Any guess? If any entity has a key attribute, it's a strong entity. If any entity does not have a strong key attribute, it is a weak entity. So there are actually entities which have which do not have a key attribute, and they are called as weak entities. Okay. 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 Any questions so far? No questions. Okay. Perfect. 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 Okay. Okay. 1 second. I'll just. Mm, okay. So have you been taught about relationships between entities? I just want to know how much I should go into. That's why I'm asking. 1:1 relationship, 1:m relationship, one to many, many to one. No. Okay. That means I have to. Okay. Let me see. 1 second. I'm just trying to find an example of a weak entity. Um, okay. Yeah. So. hmm, How do I select? I forgot how to select. Okay. I can remove my date of birth. It's no longer required. I can move this up. It's no longer required. What? 1 second. I will try to make it small. Okay. 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 It messed up the. Okay. 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 So I think many of you have been to hotels, different hotels in town, and hotels in typical have rooms, right? They have different rooms, and um, for example, let's take a room entity. Okay, okay. Let's take a room entity. A room typically has a room number. Right? Every hotel in a room has a room number. Everyone knows that, so it is one of the attributes. Okay, and the way this database is designed, a room has also something called, let's say, square feet. How much square feet is a room? Okay. With this information, can you uniquely identify a room? Let's say I tell you there is an entity, room number is 101. Okay. The room number is 101 and square feet is, let's say, 200 square feet. Okay. What will be your first question? You might ask me, which is the hotel, boss? I don't know the hotel. Many hotels can have room number 1 with a 200 square feet room, right? So can you uniquely identify a room like this? If I just give you this information, uniquely identify a room meaning out of all the hotels that exist in the planet, if I give you just this much information that the room number is 101 and the square feet is 200, can you uniquely identify a room? Obviously no, because there will be many hotels which will have a room number of 101 with a square feet of room of 200. So you cannot actually uniquely identify a room among all the rooms that are present in all of the hotels. So what should we do? So first of all, since this um, entity, that is room, does not have a key attribute, um, it is also called a weak entity. And to represent a weak entity, it is represented using double rectangle. Okay, this double rectangle means it's a weak entity. It does not have its own um, key attribute that can uniquely identify it. But somehow, if I have a hotel, let's say I have a hotel, okay, and this hotel has a something called hotel ID, and this hotel ID is actually unique. You can uniquely identify each hotel in your city or anywhere by the hotel ID. Okay, and this hotel might have a name, all that is okay. It might have number of floors, number of rooms, all that I don't care. Okay, you can uniquely identify a hotel using the hotel ID. If I give you these two information, which is hotel ID and room number, now can you uniquely identify a room? See, I'm just teaching you English, right? I'm not even teaching you databases, but this is what it is. Okay, so if I give you a hotel ID and a room number, you can uniquely identify that room because now you know which hotel it is, you know which room to go to. So somehow you will have to connect these two entities, right? You'll have to connect these two entities are separate. One is hotel, one is room. How can you connect them? To connect two entities, you use something called relationships. Okay, so relationships are like this. They are represented using a using a arrow, using a, not exactly an arrow, using a line, and there's a diamond here. Okay, and this is connected here. Okay. uh, okay, so this is relationship. And since hotel identifies a room, because if you're just given the room number, you actually won't be able to identify the room. You also need the hotel ID. So it is also called a identifying relationship. Okay, it is also called a identifying relationship. What is an identifying relationship? In an identifying relationship, one of the entities is a weak entity, and to identify an entity in the weak entity set, you will have to have a strong entity. So this is a strong entity, right? Hotel is a strong entity. Everyone should agree with that because hotel has a key attribute, which is HID. Now, in order to connect them, you use a line, you draw a diamond, and since it's an identifying relationship, you draw a double diamond. Okay. Now, what is not a identifying relationship? We'll go to that later. Don't worry. But for this case, it's like there's a line and there are double diamonds and it's a room. So you can uniquely identify a room in a hotel given the information of a hotel ID as well as the room number. Okay. Fine. Now tell me one thing. So do you agree to this statement that all the rooms that are present in the room entity set, in this room entity, there are many rooms, right? There are many rooms, right? Like Kadoro room, right? Many rooms are there in this room entity set. If any one of them does not have a hotel ID, will you be able to uniquely identify that room? For example, let's say there is a room ABC. This room does not have a hotel ID. Will you be able to uniquely identify the room? No, I mean, you have to have a hotel ID, right? That means the room entity set, which is a weak entity set, must participate totally in the relationship. A relationship can be a partial participation as well as a total participation. I will explain partial participation later, don't worry about that. But total participation means weak entity, each entity in the weak entity set must participate in the relationship. Must participate in the relationship meaning it must have a hotel ID. Okay. And there is one more thing here. Every weak entity set follows something called a one-to-many relationship, which means one hotel can have many rooms. Okay, one hotel can have many rooms. Okay, that's why it's called a one-to-many relationship. Again, let me explain this again. Room is a weak entity set. I asked you the question. If you have a room number which does not have a hotel ID, you will never be able to uniquely identify the room. So if you want to identify every room in the hotel ID, every room uniquely, you need to have a hotel ID associated to it. And for it to have every hotel ID associated with it, you must, it's a must, it's not a with, it's not a should, it's must. You must have a total participation. Now let's come back to the question. What does the question say? Now, can you see the answer? Can you understand the answer now? That the weak entity set must have total participation in the identifying relationship. Okay, is it clear now? Okay, perfect. Okay, now why does the owner entity set need not have? Because obviously see, we are not trying to identify a hotel. Hotel to already identified, right? We are already identifying the hotel with the hotel ID. We don't need to have total participation. How will the room number help to identify the hotel? But for the room entity set, we must have total participation on the owner entity set. So what is the owner entity set? Owner entity set is hotel in this case. The strong entity which identifies the weak entity is called the owner entity. Okay, so it's just a word game. Okay, don't this is my style of teaching. Never be afraid of technical jargons. Never be afraid. Okay, it's just technical jargons. Try to understand the concept. So the weak entity has a owner entity. They are kind of has something called an identifying relationship by which the weak entity set can be identified using a strong entity, and the weak entity must have total participation in the identifying relationship. It's a theorem. You can, I mean, I just explained you the entire thing actually. And also the other thing is the weak entity set must have one to many relationship in the identifying relationship. In the identifying relationship, yeah, it has to have one to many correspondence. Okay, so this is what is weak entity set, and this was the question. Okay, now before I go forward, I will just want to, yeah, this was a question I was talking about. Okay, so this is a very good question by which you can learn about ER diagrams. Okay, and it's a very good question. I mean, it's just very simple. Okay, do not worry about the diagram. Okay, I don't even know why they gave this question. It's free marks. Okay, see, this will teach you the ER diagram a lot. Okay, as you can see, there is no attribute. Why do I say that? What is the reason behind me saying that there is no attribute? What is missing here? Can anyone answer? If I can just recap your knowledge. What is missing in all these diagrams? Ellipses. They don't know, none of the diagrams have an ellipse. Attributes are represented using ellipse. Okay. Now let's go to the question. So very simple. We can see. Let S be a specification. Okay. Let's S be a specification. Instructor teach courses. Instructor do teach courses. Students register for courses. Okay. Courses are allocated classrooms. Instructors guide students. So which one of the following ER diagrams correctly represents S? Okay, let's look at the first option. Okay, instructor teaches courses. All good here? Instructor is an entity, course is an entity. They are connected with a line with a relationship called teaches. So instructor teaches courses. Okay. Okay. Now, if I ask you a question, should there be a one-to-many relationship here or a one-to-one relationship here? Which means an instructor can teach more than one course, or an instructor can only teach one course. Live example is me, but anyway, more than one. So one to many, right? That's what one to many means, right? And what would many to one mean? If I make it M1, what would it mean? It means, which is true for DBMS in your IGC, many instructors teach one course, right? DBMS, there are two teachers over here. Like there was one earlier, that's now me. So many instructors teach one course, right? So that's many to one to many, and one to one. One to one means an instructor teaches a course. An instructor teaches a course. One to many is an instructor teaches many course. Many to one is many instructors teach one course. Okay, this is what is the basic funda of relationships. Okay, so let's go back. Let's come back. So instructor teaches courses. Option A is looks like it should be correct. Let's see. Okay, let's see. Students register for courses. Student should be an entity, right? Student cannot be a relationship. Student is an entity, right? It's an object, right? So option 1 is gone. It's not correct. Okay, everyone clear why option 1 is not correct? Okay, perfect. Option 2, instructor teaches courses. First part is absolutely correct. Okay, instructor teaches courses. Okay. Student register for courses. A student is not existing here, right? I mean, option 2 is gone again, right? There's no student here, right? You can see there's no student entity or relationship, nothing is there. Okay, fine, perfect. Let's come to option 3. Instructor teaches courses. Again, same, you can see instructor teaches courses. Students registers for courses. Even this is correct. See, student registers for courses. Okay, even this is correct. Courses are allocated classrooms. Is this correct? Is this correct? No. Why not? What is the problem here? You are correct, but what? Why is it not correct? That's what I'm asking. What is the issue with this? Perfect. So see, it's like this. Classroom courses are allocated to classroom. Here it kind of means classrooms are courses to allocation. I mean, this is just right. This is not correct, right? So when you try to connect two entities, you need to have a relationship in between. You're trying to connect two objects, you need to have a relationships in between. In this case, you're trying to just connect two entities as it is, which is not allowed. Okay. Perfect. Now see, fourth option, which obviously will be the correct one because first three are wrong. Instructor teaches courses, right? Students register for courses. Again, it's correct, right? You can see that. Courses are allocated classrooms. Again, you can see that, right? Courses are allocated classrooms. Okay. Instructors guide students. So instructors guides students. So which option is correct? Number 4. Okay. Is it clear, everyone? Yes. Okay. Now I was talking about total participation and partial participation in the previous question. See. So the course entity can have a lot of courses in it, right? It can have a set of all the courses that are available in your, let's say, GATE exam. In your GATE, all the courses that are available, they are part of the course entity set. Does an instructor teach all the course? Does an instructor teach all the course? Have I taught all the core subjects of GATE to you? No, right? There are other professors, there are other instructors as well. So should course be fully, totally participating in an instructor set? Obviously, no, right? Every course, some courses are there which do not even require an instructor. You can self-learn those courses, right? You can just go on YouTube, read the docs, read the documentation. Somehow you can learn it. You don't need an instructor to do it. So course may not have total allocation of instructor, total participation in the relationship. Similarly, each course should be allocated a classroom, may not be. In my BTech, we had a course called yoga, right? And yoga, you can't do it in a classroom. You have to go outside. So I'm just trying to give you some glimpse of things, okay? How something is called total and how something is called partial, okay? Instructor guides a student. A student may not have any instructor as a guide. Possible, right? It's just, it's possible, right? So that's how it is. So that's what is total partial. In this case, everything is a partial participation. Um, okay, so this was a question that kind of has a glimpse of, it will help you to learn about ER diagrams, etc. Okay. Okay, I just taught you this. Let's see if you can answer. Which one of the following is used to represent supporting many to one relationships of a weak entity set in an ER diagram? Okay. My question is, why not B? A is the right answer. Very good. Very good, actually. Very good if you have learnt it now and answered. Why not B? What is the problem with B? Very good. Very good. So that was the twist in the question, right? So the twist was many people have answered B. Okay, this is GATE 2020. I had answered A, but I knew many of my friends who answered B, right? And the thing is, rectangle is for a uh, weak entity set, while diamond is always for a relationships. And they are asking which of the following is to represent the supporting many to one relationships, not a weak entity set. So please read the words carefully in the question. Okay, ovals and all, they don't, I don't, just bullshit. Okay, ovals and all are for attributes. You don't even have to look into those. So some people call it oval, some people call it ellipse. I mean, whatever you like to call, both look the same, so don't be confused. Okay. Okay. First, try to read the question and try to understand. Okay. Then I will let you. Uh, then I will tell you the answer. Okay. Is the ER diagram complete? What is the participation of E1 and E2 in R? Is it total or is it partial? Okay. So if it's a total participation, you have to have double arrows. Did I draw for the earlier case? Let me just see. I think I didn't. Sorry about that. I did. See, there is a double arrow, right? Double line, right? Double line means it's a total participation. Okay. So, right. So both of them participate totally in R. So every entity in E2, and they are saying that the cardinality of E1 is greater than the cardinality of E2. Okay, so these are sets, right? These are sets, which means they have a different set of objects in them, entity set. For example, you can take student, you can take course, whatever you want. Um, there are different students, and the number of students are more than the number of courses. That is always the case. So you can kind of map it like that. So the cardinality of E1 is greater than the cardinality of E2. Okay. So if it's a total participation, okay, first of all, you need to, this entire question revolves around if you know total participation. If you know, you will be able to answer. Total participation means what? It means every entity in E1 and E2 will be participating in the relationship. Okay, every entity in E1 and E2 will participate in the relationship. What do I mean by participate in the relationship? What I mean is, if this relationship is, let's say, um, let's take an example. Okay, let's take an example because E1, E2 may not be very useful. So let's say there is student, okay, stud no student, okay, and there is a course, okay, and the relationship is takes a course, okay. which means every student takes a course. I mean, that's why you are called a student, because you take some course, or else there's no point of calling you as a student. So student takes a course, right? So every student participates totally in this relationship. Do you now understand what do I mean by total participation? From the student side, every student takes a course. That's why you are called a student, or else I don't know what I will call you. But if every student, the main thing about a student is he or she takes a course. Okay. Now, from the course side, if there is a total participation, it means that whatever courses are there available here, each of these courses is taken by at least one student. Okay, is it clear? From the student side, it means total participation means every student takes a course. From the course side, it means every course is taken by at least one student. Is it clear now what is the meaning of total participation here? Yes? Okay, perfect, perfect. So I will leave it as it, but they are calling it as E2, they are calling this as E1, they are calling this as R. They are saying the cardinality of E1 is greater than the cardinality of E2. The example is perfect. Number of students are more than the number of courses. That's all. That's often the case. Okay. So first of all, look at option D. Every entity in E2 is associated with at most one entity in E1. Is this correct? At most meaning what? At most means it could not be as well. If it is not participating, Okay, I've changed my network. Let me know if my voice breaks for some reason. Okay, I can disturb the flow. Okay, so I was talking about there are two entities, E1 and E2, and they are participating totally in a relationship R. Um, Now look at option D, right? Option D says every entity in E2, which is the entity which has lesser number of elements in it, is associated with at most one entity in E1, right? And the whole point of it being total participation is it should be associated with either exactly one or more than one. Okay, so at most meaning it could not be associated as well. That cannot be the case here, right? So option D is not the right answer. Okay, everyone clear why option D is not the right answer? Yes. Okay. Every entity in E2 is associated with exactly one entity in E1. That is also not true because why? Because your number of entities in E1 is more. For example, think of it like a Venn diagram, right? So if you have each entity in E2 being associated with exactly one entity in E1, there will definitely be some entities in E1 which will not be associated with any element in E2. So you need to have an association like this. Okay, sorry, I'm not trying to draw lines like this. So what I mean is, even let's think of it like a set. Okay, let's think of it like a set. So E1 has some entities in it. Okay, and E2 also has some entities in it, and the cardinality of E1 is greater. So let's say it has only this four. Okay, it says every entity in E2 is associated with exactly one entity of E1. Let's say the mapping is like this. What does it mean? It means that E2 is participating totally in R. Every entity in E2 is associated with exactly one entity in E1. Is E1 participating totally in R? Is E1 participating totally in R? Look carefully. Is E1 participating totally in R? Are these two associated as well with an element of E2? What does total participation mean? It means every entity must be associated with something on the right. So they should be related somehow. Okay. Every entity in E1 must be related to every element in E2. Okay. So even though there is total participation from E2, because you can see all the entities in E2 associated with an entity in E1. So there is total participation from E2 side, but from the E1 side, that is not true because there are some entities which are not associated with an entity in E2. So option C is also incorrect. Okay. Now the option D says some entity in E1 is associated with more than one entity in E2. Chalo, theek hai. Let's do this. Okay. This entity let me associate with this as well. Is it still total participation from E1 now? Why not? What is the problem? I mean, you are correct, but why not? The same reason, right? The same reason. These two are not associated with any element in E2, right? So you have to make sure these two elements are associated as well. So what does option A says? Option A says every entity in E1 is associated with exactly one entity in E2. That's why you can have total participation. Okay, this is one way you can have total participation. It is not telling you that boss, you need to have exactly one. You can have more than one. It's just asking you among these four options, these three are not possible given both of them to participate totally in R, but option A is definitely possible. Okay, everyone clear with this? It's a very important question. Okay, so make sure you understand it before. Okay. Okay, perfect, perfect, perfect. Let's move on. I already told you this. So what is the answer? Which symbol denotes derived attributes in ER model? Option B, right? Dashed ellipse. Squared ellipse. Wow. Ellipse with the, okay. What is a double ellipse? Let's recap your knowledge. What is a double ellipse? Multi-valued attribute. Squared ellipse तो होता नहीं कुछ, sorry. What is ellipse with attribute name underlined? What is an ellipse with attribute name underlined? Key attribute. Very good, guys. Very good. Very good. Perfect. Perfect. Very good. Good. Nice. Okay. Given the basic ER and relational model, which one of the following is incorrect? Okay. An attribute of an entity can have more than one value. Can it have more than one value? An attribute? Yes, I mean multi-valued attribute. An attribute of an entity can be composite. Can it be composite? Obviously. Okay. Have you learned relational models? Yes, no. Have you learned about relational models, relational tables, SQL? Okay. So in a row of a relational table, an attribute can have more than one value. Is it true? Can you have more than one value in a row in a table? No. So if you have learned normalization, it's called 1NF, right? 1NF means first normal form. You cannot have any attribute with more than one value. How to solve it? You already know that in normalization, right? You need to have a foreign key, primary key, referencing the primary key. The foreign key will store the attribute. We'll go to that later, don't worry. So that is the incorrect option. Okay. Option D is also possible in a row of a relational table. An attribute can have exactly one value or a null value. So this is what it is. Option C is the incorrect option. You cannot have more than one value in a row of a relational table. Okay, very good, very good. Okay, now this is something. Have you guys learned this conversion of ER diagram to relational table? You can say no. Okay, that's absolutely okay. If you have not learned, yes. Has this been taught? Conversion of relational tables to ER diagram to relational table? No, no. Okay, perfect, perfect. No issues, no issues, no issues. Okay. Mm-hmm. Okay. So, right. We'll go to relationships later. Okay. I will not talk about relationships for a minute or two. We will just go to some of the basics. Okay. So, if you have an entity E1, having a few attributes A1, A2, right? Let's say these are the two attributes it has. It is a simple attribute. There is no composite. There is no nothing like that I've given here. Directly what you do is to convert it into a table. The name of the table will be the name of the entity, which is E1. And it has two columns. One is the attribute A1. One is the attribute A2. Okay. So far so good. This one is simple, right? Yes. Let's say there is another attribute A3, right? And let's say I underline A1. What do I mean by underlining A1? What does A1 become now? It becomes a key attribute. Very good, very good. So I need to have another column A3, and A1 becomes something called a primary key. You all know what is a primary key? What is a primary key? Yes, perfect. So A1 becomes my primary key. Okay, perfect, perfect. Now, the next complication that comes is, let's say I have E1, okay, and let's say there is a composite attribute, which means it's an attribute composed of multiple simple attributes. It has another attribute A2. Okay, it has a composite attribute A1, as you can see. So how do I model it? It's simple. The name of the table is again E1. Nothing changes here. Now I will have a column for A2, and I will have a column for the simple attributes. Okay, composite attribute will not have a column. Okay, the column will be something like this. Okay, fine. Okay, okay. Next is if I have a multi-valued attribute, and for this, please pay attention. So let's say I have an entity E1. It has a primary key. Sorry, not E1. It will be confusing. It has a primary key A1. And how do I write a multi-valued attribute? What is the notation? Anyone who remembers? Double ellipse. Very good. Very good. So double ellipse. Very good, Vishnu. So double ellipse. Okay. Now things get a bit complicated. Okay. It gets a bit complicated, but don't worry. It's still very simple. So let's add another attribute. I will call it, let's say, A3. Okay. So what happens here is, sorry. So I will have a table E1, and let's say A1 is the key attribute. Okay, it's a strong entity, so A1 has the key attribute. So I have A1 as one of the columns. It is a key attribute, so I will maybe underline it here as well. It's not mandatory, but you can do so. And I will add the simple attribute here. The simple attribute is A3. Okay, this is what I do. Okay, I underline the simple attribute. I also add the simple attribute here. I will have another table which will have the primary key of the strong entity, which is A1, along with the multi-valued attribute, which is A2. And this attribute here, A1, becomes a foreign key to this table. Everyone knows what is a foreign key? Have you been taught what is a foreign key? Yes. So A1, now why do I do this way? There is a normalization called 3NF. Okay. And if you do this way, your table will be in 3NF. Okay. That's why we do this. Okay. There is no other reason. To make sure that your table is in 3NF, third normal form, we try to do it in this way. The multi-valued attribute is translated as a different table with the primary key attribute as one of the columns, and along with the multi-valued attribute, the primary key column becomes a foreign key to the original table. Okay. This was all about translating entity sets into what shall I say, into tables. Now comes relationships, which kind of gets a bit tricky, but it's still don't worry, it's not very difficult. Right. So before I continue, any questions with this part? Anyone who didn't understand any of the conversions? Okay, okay. Silence means all good. Okay, perfect. Um, okay. So let's draw a relationship. Let's say it's E1. Okay. It has a primary key attribute, let's say A1. It participates in a relationship, total or partial does not matter in this case. And E2 is another relationship which has a primary key attribute A2. Okay, let's say this is this, even relationships can have attribute, guys. Okay, I'll give you an example of that as well in some time. Even relationships can have attributes. Let's say it's called AR. Okay, now to convert this into a table, E1 will have its own table with only one column, which is A1. Okay, E2 will have its own table with its own column as A2. Okay, E1 will have its own table with A1 as a column. E2 will have its own table with A2 as column. This is all from the previous few minutes that I have taught. When it comes to the relation R, the relation R will have its own attribute, which is A of R, along with the key attributes of the participating entities. The participating entities in the relationship are E1 and E2. Their key attributes are A1 and A2 respectively. So the relation R will have A1 and A2 as the other two attributes. And A1 and A2 together will identify a unique tuple or unique row in this table. Okay. Okay, clear? Understood? I'm just telling you the algorithm. I'll go to that. I'll go to that, Vishnu. Don't worry. I'll go to that. That's weak entity. I'll go into that. I'm just talking about strong entities now. Okay. Okay. Yeah. Perfect. So now assume that there are actually what shall I say? There are sorry. There are no attributes in the relation. Okay. If there is an attribute in the relation, in this case, there is an attribute in the relation R. For example, if I give you an example, right? If I give you an example of a relation which can have an attribute, so an employee works in a department. So employee is one of the entity, department is another entity, works in is another, is a relationship. So an employee works in a department. If an employee works in a department, the number of hours he or she works is dependent on the relationship, right? Let's say I work in the department of computer science in IIT Madras. I might have some hours there. I might work in the department of IGC where I teach. So I have some number of hours there. Each of the relationship, the participating entities will have its own number of hours associated with it. An employee may work in two or more departments. Each of those departments have a different number of hours. Each of them will have different salaries, different wages. All that are parts of the attributes of a relationship, right? So there's a question as well later on in this presentation. We'll try to understand it from there as well. So now let's, as I was saying if there is if there is no attribute in a relationship, right? That's when you can optimize things a bit. Okay, this is for optimization. And I don't think I have the next slide. Okay, should I do? I'll write here. Okay. So for relationships as well as especially binary relationships where there are no attributes of the relationship, how do you do it? Okay. So there can be four cases, right? There can be four cases. One of the case being, sorry, there can be three cases, not four. So the first case is there is a one to one relationship. Okay, there's a one to one relationship. For example, here there is E1. Okay, there is a relationship R. Okay, and there is E2 here. Okay, E2 has a key attribute. I call it A2, let's say, and E1 has a key attribute. I call it A1. Okay, and let's add a few more attributes. It has an attribute, let's say A3. It has an attribute, let's say A4. It can have a few more attributes. That is not that is okay. Okay, so you have two options. Either you can have a table for E1, which is you can have an attribute like this. You can have a table for E2, which is something like this. And you can also have a table for the relation R with the key attributes from the two relations. This is one of the way. But as you can see, the relation R, the table of relation R is redundant because it does not have its own attributes. So there is no, you're not actually adding any additional information by having the relation R. What you can do alternatively is you can choose to include the key attribute of E2 in E1 or the key attribute of E1 in E2, which means you can do like this. You can do this. Okay. And this E2 acts as a foreign key, acts as a foreign key to A2. For people who have working professionals here, who have worked on databases, right? You will see this a lot. There will be a foreign key referencing another table. And that this is the main concept from where it comes. So what you can do is you can include the key attribute from E2 in E1, or the other way around, you can also include the key attribute of E1 in E2. Both of them is absolutely okay. It's your choice for a one-to-one relationship. In this way, what is the benefit I am getting? The benefit that I am getting is I do not have to have a extra table. Okay, is it clear? One-to-one relationship, how do you model it in a diagram? Right, but there is an exception with here occurs when there is a many-to-many relationship. Again, there are normalization constraints that are there. So if there is a many-to-many relationship, sorry, you will have to have a separate table for the relation R. You cannot do anything, even if the relation R does not have an attribute. So if you have a many-to-many relationship, your E1 will have its own table. Sorry, A1, A3. E2 will have its own table, A2, A4. Relation R will have its own table, A1 and A2. This is done to only do normalization. Okay, there's a big reason behind it. I will encourage you guys to read on it. Okay, I don't want to explain it now, but it's a big theorem, big reason. Okay, and there's a big, very beautiful concept between this. They actually proved it using examples where they are saying it's not 3NF, it won't be 2NF as well. So you can look into that. Else I will take it up one day. Okay, so in many-to-many relationship, just remember you will need to have two different entities. Okay, sorry, you need to have a separate table for the relation R. Now things kind of change when you have a one-to-many or a many-to-one relationship. One-to-many or many-to-one relationship. Okay. If you have a one-to-many or many-to-one relationship, you will have to add the foreign key in the many side. So what do I mean by it is, what do I mean by it is, take the example on the left. If there is a one-to-many relationship, the many part is belonging to E2, right? So you will have to add, so E1 will be as it is, so A1, A3. But for E2, you need to add the primary key of E1 here, which acts as a foreign key. So the foreign key you need to add in the many side. Okay, you need to add the foreign key in the many side. This is for a one-to-many relationship. And for a many-to-one relationship, things go reverse. Sorry, should be even. Your foreign key will have to be in the E1 side. Okay. This is for um, sorry, many to one relationship. Okay. Okay. So these are some of the rules that you will have to uh, uh, keep in mind. Now the thing comes when there is a weak entity, right? And I don't have space for that. Let me create space. 1 second. Okay. 1 second. Right. Okay. So weak entity. Okay. Weak entity set. Weak entity set meaning there must be a strong entity, which is the owner entity, right? There will be a strong entity which has a identifying relationship which looks like this, and the weak entity participates totally in this identifying relationship. And since it's a weak entity, it will obviously not have. Okay, sorry. If you remember the beginning of the lecture, I told you two things about weak entity and its relationship. One thing I told you was it is a total participation. It should participate totally in the relationship R. What is the type of relationship? Should it be a one-to-many? Okay. Am I audible now? Yeah. So as you said, actually, so there should be a one-to-many relationship, right? There should be a one-to-many relationship. If you apply rule 3, where will you place the foreign key? Will you place it in E2 or will you place it in E1? Where will you place the foreign key? It says add the foreign key in the many side. The many side is in E2. So we'll place the weak entity in the foreign key in E2. Perfect. Perfect. Very good. Now let's come back to the question, right? The question says how many number of tables you need to represent M and P R1, R2. Okay. So how many tables you need? Assume the relationship is such that you have minimized the table. Okay. The cardinality ratio, which is either 1:1 or many is to many is to many to one or 1:1 or many to many. Assume that the cardinality ratio is the minimal. Okay. Okay. Will M require a table? Will you have a table for M? Yes? No? Will you have a table for M? You must have a table for M. Will you have a table for P? Yes, because M and P are strong entities. Strong entity must have a table. Okay. Assume there is a one-to-one relationship between M and P. So this relationship R1, right? This is one-to-one. Okay. So what can you do? Can you place the attribute P1 as a foreign key in table M? Yes. No. Yes. Yes. Right. You can, because it's one-to-one. You can place in either M or P. So you can place it in M. You can place it in P. So I can place this in M, right? So my M table is kind of complete. There is a primary key M1. There are two other simple attributes, M2, M3. There is a foreign key P1. Okay, this part is clear, everyone? Okay. What should be the attributes of capital P? One is P1. It's its own key attribute, right? And what else? What is another attribute of P? It's given in the diagram. P2, right? P2 is another attribute. Okay. Can I place N1 here? Can I place N1 here? No. Why not? What is the issue? What is the reason behind not placing N1 here? Because the relationship is many to one or one to many. It is one to many, right? I mean, that's the thing. So it's one to many. So you need to place the attribute on the many side. Okay. So can't do that. Okay. What else? Do I need a table for N as well? If yes, what are the attributes? What are the attributes of N? N1, N2, P1. Very good, Vishnu. Very, very good. Perfect. Perfect. Very good. N1, N2, P1. Others, anyone has any questions? You should have a question, guys. I don't know why you're not asking. Okay, any questions, anyone? Why is N1 underlined? If it's a weak attribute, why does it have a key attribute? Anyone who thought this? I said a weak entity is an entity which does not have a key attribute. But N is a weak entity, which is it is a double rectangle. It has a key attribute. So why is it a weak entity? See, that's the whole point. Okay. So the thing is, what it means is, okay, there are some entities, in this case, in a weak entity. Let's take the hotel example only. Okay. Um, so for example, it might sound funny. Okay. My example might sound funny, but that's how it is. So, um, let's say room number. Okay, let's say I underline room number. Okay, and the square feet. Okay, so room number is, let's say, 100. Square feet is, let's say, 200. This may uniquely identify a room. Understood, everyone? This uniquely identifies a room which has a number 100, which has a square feet of 200. But of which hotel? Understood? There can be many hotels which has a room number of 100 and a square feet of 200. In this entity N, which is room, 100 is a unique entity. Room number 100 with a square feet of 200 is a unique entity. There does not exist any other room with a number 100 with a square feet of 200. Okay? But once you club it with a hotel, once you club it with a owner entity, which is hotel, there could be a hotel which has a room number 100, square feet 200. There could be another hotel which has a room number 100, square feet 200. But if you just look at this entity as a standalone entity, forget the hotel. 100 is a room number that is uniquely identified having a size of 200 square feet. Okay, it's like you have a unique way of identifying a room, but that is not very strong enough. It's not like if I say you there is a room number 100 of square feet 200, you will ask me, okay, there could be uniquely a unique room number 100 of square feet 200. That's correct, but which hotel? You need to know the hotel as well. Which hotel? Which hotel you are talking about? Is it a hotel? Is it a school? Is it a classroom? What is it? Right? So that's why it's written like that. So you don't need not worry about it. The thing that you have to look into it is weak entity means it should have a double rectangle. Okay. Anyways, let's come back to what we are trying to talk about. So minimum number of tables needed to represent MNP R1 R2 is what? So what is the answer of this question? What is the answer? How many tables do you see? 3, right? Okay. What is the maximum number of tables that can be there? Can there be one more table? If yes, how? You just learnt it some time back. If the relation R1 is what? If the relation R1 is many to many, then you will have to have a table for R1 as well. That way your number of tables will be 4. They are asking minimum number of tables. In this case, it is 3. Option B is the right answer. Okay. Now there is a follow-up question as well. They have asked. They asked. Right. Okay. I kind of jumped a question. Sorry. So there's a follow-up question based on the same question that they have asked. They are saying the minimum number of tables needed to represent. Oh, just ignore this. Sorry, why I'm doing it's not there. So it's the same ER diagram. Okay, they have drawn the same ER diagram. They are saying which of the following is a correct attribute set for one of the tables mentioned in the that you have drawn the schema for. So let me write the schema again here. So the schema for M was M1, M2, M3, P1. The schema for N was N1, N2, P1. The schema for P was P1, P2. Right? This was a schema we had. Now they are asking which of the following is a correct set of attributes for one of the tables that you have drawn. See, the answer is there in the question now. What I have wrote, there is an answer directly. Which option is correct? Jigya says option A. Option B, is it correct? Can it option B be correct? Is there a table with the attributes M1, P1, N1, N2? There is no, right? You can see. There is no table with attributes M1, P1, N1. There is no table with attribute M1, P1. There is a table capital M which has the correct attribute set M1, M2, M3, P1. Okay, any doubts regarding any of the questions that we had so far? Can I proceed? Can I proceed? Two more questions are left. Okay. Yeah, it's a very good question. Consider the entities hotel room, person. It has a many-to-many relationship named lodging. So many person, they kind of stay in a hotel room. So lodging is one of the relationships they have given here. If we wish to store the information about the rent paid by the person who has occupied different hotel rooms, where would you want to place this information? If you want to answer this question, ask yourself, Acha, there is a hotel room, it's an entity in itself, like different rooms are there with different sizes, different features and all that. There is a person entity which has its own features of a person, which is name, age and whatever. And there is a relationship called lodging. Lodging means, let's say it takes a room, renting a room, okay? It books a hotel, it rents a room. So the rent payment that is associated with the room, do you want to place it in the hotel room? Do you want to place it in the person? Or do you want to place it in the relationship? The rent payment, is it part of the relationship? Do you guys agree to this? If you let's say book a room, let's say this person is you. Hotel room is some XYZ hotel. You go and book a room in that hotel. The rent payment will be associated with the relationship, right? See, don't just agree to whatever I'm saying. Try to understand, okay? Hotel room has its own entity, which is it has a room number, it has different features in it, number of bathtubs or whatever it is. Person is an entity, it has its own feature. When the relationship is made between person and hotel room, which is lodging, the rent payment that is associated when a person books a hotel room should be associated with lodging. Correct? Do you guys agree to this statement? Do you understand what I'm trying to say here? Yes, everyone, not just Rohit. Everyone, do you guys understand what I'm trying to say? For example, if I take another example, let's say a student, okay, takes a course. If I ask you the grade information, the student will have a grade. If student takes a course, it will score some marks, it will have a grade. Do you want to keep the grade in the student entity. In that way, you will have to also keep the information about the course, which is this is the course number and this is the grade he has got. Do you want to associate it with the course? So you want to say there is a course math, the grade is A. I will ask you which student got the grade A. You will have to store the student information. Alternatively, what you can do is you can store the grade information in the relationship. So in that way, what will happen is your table will be like this. So student ID, course ID, and this is the grade. So this student A with the course ID B got a grade O. O in my college was outstanding in my BTech college. So student ID A taking a course B will have a grade outstanding. So it's always good to have a relationship attributes which are part of the relation in the relationship, okay, not in the entity, neither the not in the either entities. It's always better. I'm not saying it is mandated. You have to keep. Nahi, aisa, there's nothing like that. It's your choice, but it's always preferred to keep it in the relationship. So in this case, it should always appear as an attribute in lodging. If I ask you Aadhaar number, do you want to associate it with the person? Yes, because person is an entity which has Aadhaar number. You obviously don't want to put it in the hotel room because it does not make sense. Okay. Last question is this. So this question is a bit of a challenge, okay, because it's not very easy. Let me be frank, it's not very easy. The thing is, if you just what shall I say? If you just sorry, if you just convert it into a relational table directly using whatever I told you, you will get the answer. Okay, so take this as a homework. Okay, that's why I kept it as a challenge, and take this as a homework. Please make sure you are doing it. In the next class, we will look into this question and then we'll talk about functional dependencies. But please look into this question once on your own, because I really would encourage you to look into this question, because if I tell you the idea is not very complete, right? If I tell you everything, then you guys are appearing for the exam, not me. I've already done that. Okay. So please try this out. It's a homework from my side, and we'll discuss this in the next class. Before I end, any questions regarding today's lecture? Any topic do you want me to kind of talk about more in the next class? Any questions? No questions? Okay. Okay. Very good. Very good. Um, okay. So in the next class, we will talk about functional dependencies. Your DBMS class is over, and I got a doubt from one of the students in compiler design. So I'll take that up. For students who are who the DBMS class is over, so feel free to exit the room. Thanks for joining. If you have any questions, feel free to speak up. Feel free to type it on the chat. Okay, so this was one of the questions. For the last question, is lodging the correct answer? Is the person can be is the person can it can be person as well, right? Okay, very good question. Let's come back to it. See, as I said, it can be person also. Okay, Vishnu, it can be person. Okay, but the practice is that always attributes that are part of a relation. Okay, rent payment is an attribute only associated once you have this relation called lodging. If you do not have this relation at all, let's say you do not have this relation, right? Will you have a rent payment as one of the attributes of person? No. And why won't you have it? Because then in that case, you will have an unnecessary column lying on your database, right? which you will only populate once there is a lodging database. Once there is a lodging entry. Once the person has taken some lodging, then only you will populate that rent. So the person might have another relationship over here. He might have another relationship over here, right? So you will have to maintain this rent payment as one of the attributes as blank for these relations as well. Is this a good database design? No. But can you do it? Yes. But is this a good database design? No. That's why the best way is to, when the attribute is part of a relation, always try to keep it in the relationship. Is it clear? Yes? Okay, perfect. Perfect. Okay, so this was one of the questions that was asked on compiler design. It was asked by Jigya. So did you see the mistake that you have done, Jigya, first of all? Are you there or you are offline? Okay, you are typing. Okay. Didn't get the mistake. Okay. Okay. So I'll just tell you the mistake that you have done. Okay. Because I think let's not bore people who are here trying to learn DBMS. What is use of B1, Jigya? What is use of B1? ABC, sure, that's it. Why not X? Aren't you reading X? Aren't you using X? Aren't you reading X here in B1? Then should X be a part of the use as well? You're using X, right, for B1? You're trying to branch from B1 to either B2 or B3 by whatever the value of X is. So you're using X, right? Is the understanding correct? Yes. So the use of B1 will also have X in it. Please try this out and please redo your calculation. You will get the in of B1 as 4 element, and that's why you will get the answer as B. Okay, is it fine, Jigya? Okay, perfect, perfect. You understood, right, why X should be there? It's not that I said because it's there. It should be there because, as you can see in the basic block B1, you are using X, right? You are using X to compare it with A and deciding if you need to go to the true branch or the false branch, but you are using the value of X, right? Okay, perfect. Okay, okay. Try this out and then we will, if you still don't get it, let me know. We'll take it up in the next class. And others also, feel free to ask any doubts you have, since you guys are practicing questions, I guess, now, because it's already December, 2 months. So 2 months goes by in a flash. So if you have any doubts, feel free to ask them in my WhatsApp. I hope you guys have my WhatsApp number. In case you don't, please let me know. I'll just share it with you. Please feel free to ask any doubts you have. If you want me to cover any concept, anything, okay, I will be happy to take them in the next class. Okay, so without further ado, I will share the slides on the chat window. You don't have? Okay. This is my WhatsApp number. Feel free to message me. Drop me a WhatsApp message if you have any questions, have any doubts. Feel free to ask. I will be happy to take them in the next class, just like how I took in this class as well. Okay, thanks for joining. Feel free, please download the slides. I do not have the Google Drive link yet. I will ask for the Drive link and then I will be able to upload. it's better if you wait for a minute and download the slide as it is now. If you can wait, if you think you can wait, then feel free to exit the room. Thank you for joining. Oh, I forgot to stop the recording.